Hey, I'm Brett Lonergan, and my project is portable navigation using sensor fusion. Here I am at a soccer pitch that I can use to reference it against Google Earth and collecting data.
The estimation retrieved from the sensor fusion program is derived from an algorithm known commonly as a Kalman filter or a linear quadratic estimator. This algorithm is a statistically optimal filter that produces estimates on the current states and their uncertainties. It uses a two-step process which includes a prediction stage and an update stage. The first stage is where the accelerometer is sampled and the reading is fed through a prediction state matrix. It is then compared against an observation variable, which in this case is the GPS. These two values are compared using weightings, and then an estimate is retrieved for that iteration. In the earlier shot of the data collection, that dataset can now be displayed in Google Earth as an overlay. In this dataset, many of the key features can verify the improvements of the filter to that of the solid GPS reading. In this overlay, the blue line represents the GPS data, while the red line represents the estimation filter. In this dataset, the first GPS reading is used as a base reference. Fortunately, the GPS accuracy improves as the receiver GPS velocity increases, as can be seen. During this initial period of startup, the estimation makes the best from what it is given, as shown by the clockwise route. At the final part of this route, the primary strength of this filter is displayed. When the GPS spikes out as shown by the disturbance, the estimation is able to either reduce it, or in the case shown, completely nullify the disturbance. Our primary issue with the IMU is the start turning association with corners, which can mess with the readings. Although it drifts a small amount, it is still within variance as it stops. Most disturbances are either from the sharp turning or a GPS error known as random walk, whereby the GPS reading will wander off course. In these situations, GPS can sometimes drag the estimate off course and then leave it there if the location was then used as a stop.
And here is a brief demonstration of the output UI, which as you can see includes the acceleration, the orientation, and the estimate, which is then compared against a Google map. And as we move, the estimate and GPS measurements track the path across the Google map.